Welcome back to this third class in the series. In this class, we're going to go over how to launch a TNT-20 and an NFT contract on the Theta Blockchain. So for a contract to be considered a TNT-721 contract, which is an NFT contract, it has to have these functions in it, which simply, the first function is the balance of an address returns how many NFTs it has. The owner of a specific token, who owns it, the address. So owner of token 1 returns an address. The safe transfer from, approve, set approval for all, get approval, and get approval for all. So basically, you need to be able to transfer an NFT and get a balance of and get the owner of. And then these other functions have to be in there for it to be considered a 721 contract. Now let's take a look at events. So an event is what prints on the actual blockchain outside of the smart contract. So events come in super useful if you want somebody to interact with the contract and do something, and then you have a server listening to the blockchain to see what that contract was interacted with. So for example, I want to take a payment in my contract for an NFT. So as soon as that NFT receives payment, I want to create an event that it received payment to mint the NFT, and then my server on the back end is going to see, hey, this NFT was minted, and it was minted by so-and-so, and now I need to go do X, whatever my server is designed to go do. In an NFT contract, it just has to have 3 events to be considered an NFT contract: a transfer, an approval, and an approval for all. We're going to take a look at the blockchain and see this transfer and what it looks like on the actual blockchain. To look at the event data, we're going to go to thetascan.io. We're going to click on tokens. Then we're going to click on TNT-721 NFT tokens. We're going to scroll down and we're just going to pick a random NFT. Let's do this one. And then you're going to click on the hash. And it reads the blockchain data. So this is saying tokens were transferred from this address to this address, and it was for token 384. So NFT 384 was transferred from this address to this address. Now let's take a look at what that looks like on the blockchain. So this is decoding it for you. If we go to view raw transaction, you're going to go down to where it says receipt and then logs, and then under topics is the data. So this first address is usually the sending address. Number 2 would be the receiving address, and then number 3 is going to be the token that was transferred. So when you see 180, and if we go back, it was token 384. Well, this is in hexadecimal and this is in decimal. So when we convert 180, we get token 384. All that is left for us to do is create our NFT contract. And for the NFT, I'm just going to use OpenZeppelin's NFT generator so I can show you guys how it works and why I wouldn't use it in the future. And let's test that out. The easiest way to create an NFT contract is to go to OpenZeppelin and then click on ERC721. Choose a mintable contract that has URI storage. So now we have our contract, and you're just going to copy that, and then we're going to go back to Thetascan, and you're going to click on Smart Contract HQ, Remix, we are going to create a new file, and we're going to name this NFT-open, and then you just paste it in. So this is the NFT contract OpenZeppelin wrote for us. So we now need to compile it. So we want to make sure that the solidity number matches the compiler, and we're using 27. And on Theta, you don't want the EVM version to be in default. You want it to be on Berlin. And then we're going to compile. Now when you use OpenZeppelin, this is going to take a minute to compile. And I'll explain why here when it's done. So what is scary for this contract for me is it appears to only be calling in 3 files. So it's importing 3 files. But when we come down here, it is actually using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20 different contracts to create your token. So your actual token is this my token. So 20 contracts went in there, and you have to trust that all 20 of these contracts don't have any vulnerabilities in them at all. So that's what makes this the scariest part, is these could have vulnerabilities. But it will work. We can come over here and we can simply deploy it. Whoops. We have to choose the right contract. And it's going to ask for an owner address. So we're going to make ourselves the owner. And we can deploy it. And then we get all the functions that are in the contract. So the name of the contract was my token, which is set up right here, my token. And if we want to mint a token, it's a safe mint. So we're going to say who is the token to, our address. We're going to give it a token ID of 0. And the string can be www.test1.com. All right, and we're going to transact. And that just wrote. So now when we come down here and we get the token URI of 0, it's going to come back to test1. And if we get the owner of token 1, oh, sorry, we don't have a token 1. We have a token 0. It's going to get my address I put in. And that's just the address that's up here in the account. And that is how you can create an NFT token super fast. And if we want to deploy this on the blockchain, we are going to come back to where we compiled it. And under where you compiled it, you're going to see 2 buttons. One is bytecode and one is ABI. So you want to make sure you have your token contract selected, which the contract we're using is my token. Make sure that is selected. And then we're going to copy the bytecode and copy the ABI into the smart contract HQ. So we are going to go to deploy a contract. And then we're going to copy the bytecode in. And just paste that in there. And then we're going to copy the ABI. And we're going to paste that in there. So the ABI is how you interact with your contract. And the bytecode is your actual contract. Then simply choose next. And we are ready to send it to the blockchain. So we are going to click connect. MetaMask is going to open if it hasn't, and it's going to ask permission to connect. And now our wallet is connected. And now this contract wants a constructor variable, which is the owner. And I will talk about that more in a minute. So we're simply going to put our address in here. And then we're going to estimate the gas. So to launch this contract, it's going to be 13 T fuel. And at this point in time, it's going to be 38 cents. So we are going to click deploy. MetaMask is going to open and ask us to confirm it. And we're going to confirm. And this is our transaction hash. And this is a contract address that just deployed in the blockchain. So we can copy this. And now we should interact with our contract. So let's open this in a new window. So we keep all this data up here. We're going to paste in the contract address. And now we need to go back to Remix and get our bytecode. So we're going to copy that out. And we're going to paste that in here. And we're going to select next. So if your wallet is auto-connected, you can just start going with it. But if you need to connect, you click on that. And then you scroll down and we can read from our contract. So we can get the name of our contract, and it's my token. Now if we want to mint a token, let's mint one. We will send it to ourselves. So we have to get our contract address. And we're going to send token 0. Actually, let's send token 100 to ourselves. And in the URI, let's name it I am learning.com. All right, so that is the URI, and then we simply click write. MetaMask will open, and the network fee is like a penny, and we're going to confirm. And once it writes to the blockchain, you're going to get a transaction hash under here. And sometimes it takes a minute to write, so we're just waiting on that to confirm. So now it's confirmed, and you can view it on ThetaScan if you want. But we can now go get the token URI, and if we type in token 0 and read, there's no URI. And if we type in token 100 and click read, we get I am learning. And that's our first NFT on the blockchain. Let's take a quick step back and look at how to deploy our contract right in Remix. So to deploy our contract in Remix, you're going to go to compile. You're going to make sure that you have your EMV version set to your contract version. And then you're going to have to go to advanced configuration change the EMV version to Berlin from default. So it's going to be set to Berlin. And then we are going to compile our contract. After the contract compiles, you're going to click on deploy. You're going to change the environment from a JavaScript environment that you're testing in to injected Web3. And it's going to grab your MetaMask wallet address, and you'll see it displayed right here. To verify that, we're going to open MetaMask, and we're going to copy in our wallet address, and we're going to paste it right here. So it ends in 926B0, 926B0. And then we are going to deploy our contract. So you can just click transact or the deploy button. MetaMask will open, and it's going to tell you that it's 32 cents to deploy the contract. And let's get the T-Fuel amount. It's going to be 12.34 T-Fuel. To deploy it, simply click confirm. If you just launched the NFT contract for the first time, you have to give it a couple minutes. But if the NFT contract has already been launched, it should be just a couple seconds. So with some time magic, we go to Theta Scan, we enter the contract address that we just launched. It's going to pull up the NFT as my token, MTK. And there's no send transactions, but there are some TNT-2021 transactions. And 10 minutes ago, we have the transaction I minted from nothing to myself for token 100. And if you click on the hash, you'll see right here it went from 0 to myself, token 100 on the contract. Oh, let's take a look at the raw contract too. So here, you'll see that number 1 under logs topics is 0, created from nothing, to myself, token 100, which 64 would then translate to 100. Now we're going to take a look at creating a TNT-20 contract. It's actually far easier than an NFT contract. I skipped over constructors, so now it's time to go back to it. A constructor is simply a function that gets launched when you first create your contract. So the constructor function is ran when you deploy your contract on the blockchain. So in this function, we're just setting the owner to the person who sends the contract to the blockchain. We're naming the token, and we're giving the token a symbol. And you can also pass these variables through the actual function, so you would enter them when you deploy the contract. And that would be useful if you were going to create, like, say, 20 TNT-20 tokens, and you want to name them all differently. You probably wouldn't want to make these static names. You'd want to pass them in the constructor, so every time you launch the contract, you would enter the new name of the token. So what makes a contract a TNT-20 token? Well, it has to have these functions in there. So it has to have a name that returns a string. It has to have a symbol that returns a string. It has to have the decimal places, the total supply of tokens. You have to be able to return the balance of from an address as a number. You have to be able to transfer those tokens from an address, approve, and give an allowance. And approve and allowance are so you can interact with smart contracts. But these functions have to be in your TNT-20 contract. And then last, it has to have simply 2 events. So it has to put some data on the blockchain. We have to have an event of transfer and an event of approve. So you have to kick out to the actual blockchain from your contract the transfer events and the approval events. Now let's create ourselves a TNT-20 token. So you have to have the compiler version you start with, and then we're going to have to next do a contract, and we're going to name it my TNT token. And then we want to give it some functions. So one of the functions it has to have is a name. So we can simply do string public name. And that's the function that returns the name. And then we have to give it a symbol. And then we're going to have to give it decimal places. And decimals are important because we need to know where the decimal place is in the blockchain. So does the token have 18 decimals? Does it have 5 decimals? Does it have 20 decimals? And I didn't make that public, so that would give us not be a TNT-20 token because it has to have the word public there. And next up, we need to do total supply. And next up, we're going to have to do some mappings. So we want to do mapping address to a uint, and this has to be public, and it's going to return the balance of. Then next we're going to have to do the allowance mapping. So we're going to go address goes to another another mapping of an address, which then goes to a uint, which is an amount. And that's going to be the public allowance. And then next we need to do an event of a transfer. And that will be an address indexed from, and an address indexed to, and then a uint value. Next, we need to do another event because it has to have 2 events to be a TNT-20 token. And this will be an approval. And this will be an address that is indexed for the owner of the tokens, and an address that is indexed for the spender of the tokens, which would generally be your contract. And then they have to send a value through. All right. Now, what did we just create here? So we just created a name, symbol, decimals, total supply, balance of, allowance, and then 2 events. When we look back at what it requires a name, symbol, decimals, total supply, balance of, all that we have the allowance. So we have to, all that's left to create is our transfer from, and approve functions. And our TNT-20 contract is ready to launch. And we've even created our event for transfer and approval already. Now that we've created all our functions, we need to give all those functions some data. So let's create the constructor. And we're going to name the contract as my token. And we are going to give it a symbol. And that can be M toke. Then we need to do the decimal places. And 85–90%, maybe more, have 18 decimal places. So when you're doing your contract, I would probably just use the 18. And we need to set the total supply. And to do that, you can 10,000. I'm going to do to the 18th power. Now you could punch out 18 zeros here after 10,000. So it'd be like that, but it's a really big number and it's harder to read in the contract. So I'm just going to use 10,000 to the 18th power. And then we want the balance of the sender's address to equal the total supply of tokens. So when the contract's created, we want all the tokens to be sent to the creator of the contract. And then we're going to simply emit a transfer event from address 0 to the sender. And we are going to send the total supply. And that's our constructor. So now we've created a name and we've given it a name. We've created a symbol function. We've named that symbol function and it's going to return a name. We've created a decimal function and now it's going to return the decimals. That leaves us to create just 3 more functions. So let's start by creating a function for transfer, and that will be the recipient, and they need to receive an amount. And that's going to return true or false. And then let's require that they can't send it back to us, right? We don't want it to end up in this contract because we're not going to add a function to be able to pull funds from this contract. So the recipient is not allowed to send to address this. And that's going to say they cannot send to this address. And if you want to put a warning message in there, you can say you cannot send these tokens to the contract. to, I should just say this contract, right? To this contract. All right, and then we're going to do balance of the sender. And we got to do message.sender minus equal, so we're going to subtract from amount, and balance of recipient plus equals amount. So we are going to add to them. And then we need to send it to the blockchain, so we're going to emit a transfer for message.sender. And then we're going to emit the recipient, and then we're going to send the amount. And we are going to return true because it went through. So if something fails, it'll return false, but if it goes through, it'll return true. The next function we need is a transfer from. So we can copy this function and paste it in, and then we're going to change this to transfer from. And since we're transferring from, we need an address of sender, and then recipient. Oh, I made a mistake here. So this won't work because I don't have recipient right here. And this should be recipient, not recoverable. All right, perfect. So then we're going to do the amount, external bolo, and we want to say you cannot send it to this address. Perfect. Balance of, we're going to omit, and then we need to add one more line right here, and we're going to put the allowance in. So we're going to say allowance of sender message sender minus equal to amount. So this says if there's an allowance where they can pull from your address, then take it away and subtract from that amount. If there is no allowance, then the transaction will just fail. And then the last function that we need to create is an approve function. So we are going to copy this over. We're going to change it from transfer from to approve, and we don't need a recipient in this one. So the sender approves an amount, and it's a bolo. We can get rid of the balances, and we can get rid of the require because we're not setting any tokens. So on this one, we simply do an allowance equal to. So we're going to change this to equal. So we want to say the sender picks an amount that can take from their contract, so that equals that amount, and then we're going to admit an approval. And message sender, recipient, and amount. Oh, and then this needs to be sender. All right, so sender. And the one thing that is wrong on here is we need to change this and put this one here and put that there. All right, so we need to do an allowance message sender, and then sender equals amount. So now that we have our contract written, it's the moment of truth. Did we make any mistakes? So we're going to come over to the compiler. You want to make sure the compiler is set to the right version. So we got 8.18 and then 8.18. And we're going to hit compile. And it's kicking me out an error. Oh, the contract isn't supposed to have parentheses there. And we're going to compile again. And it looks good. The only error we got is that it doesn't have a license at the top, which we're not going to worry about right now. So now we can test it out. So we are going to deploy our contract. All right, so we have my token contract. We can get the name, which is my token, the symbol, and then the total supply. And then if we want to transfer, we're going to pick another address, and we're going to transfer some tokens to them. And let's transfer a whole bunch of tokens to them. All right, so then we're going to get the balance of their address, and they have that many tokens. And then we can come up here and we can get the balance of my original address, and it's missing that many tokens. So the contract works. Now let's try one thing to test out here. Let's say we pick this address who shouldn't have any tokens, and they want to send that many tokens to that person. And we come down here, and we pull this up a little bit. You'll see that the transaction failed because they don't have any tokens. And you can come down here into debug mode and see why it failed. And if you have an error message in there, it'll kick it out, but we don't have an error message in there. So it's just they don't have the tokens, so it's coming back as false. All that is left to do is deploy this on the blockchain. So we're going to go back to the compiler version, and we're going to copy the bytecode. We're going to come back over here to Theta Scan. We're going to go to Smart Contract HQ. We're going to go to Deploy Contract. We are going to paste in our bytecode. We are going to grab the ABI, and we're going to paste that in. We're going to hit Next. Now our contract is going to cost us 6.41 TFuel to launch, or 18 cents. So to launch a TNT-20 contract that's as simple as this one, it's 18 cents. Now your contract could have a lot more functions, and it could cost you $1 or maybe like 50 cents. So it could be like, 50 TFuel tokens or 20 TFuel tokens or something like that to launch it. But this one's really cheap because it's really small. So we're going to deploy it. MetaMask is going to open. And we're going to confirm. You get the transaction hash immediately. And we just have to wait for the contract address in the blockchain. Once the contract address appears, we can copy that. Now we want to interact with our contract. So we're going to open this in a new window so we don't lose this data. And we are going to put our contract address in. And then we're going to have to get our ABI. That's how we interact with our contract. We're going to paste that in. And we're just going to send those to zeros so it doesn't affect anybody. And let's write that to the blockchain. MetaMask is going to open. And it costs a penny. We're going to confirm. Now, for some reason, we didn't get the transaction hash back, so it didn't return one. That's okay. It still went through in the blockchain. So we're going to go through and get the balance of, and we're going to check our address. And you can see that one token's been removed. And if we had checked the zero address, it'll have a balance of 1. And we've just created our TNT-20 contract. I went back and looked at the error we had with total supply. And the one problem that we have is when we set the total supply in the constructor, it doesn't actually put it into this variable into total supply before the function completes. So this is defaulted to the total supply. So we need to remove it from here. And then we're going to have to put it up here. So we're going to make the total supply up here, so when it goes into the constructor, it already knows the total supply number, and then it can transfer it to the token creator. And that fixes our problem. Now that we've just created a TNT-20 and an NFT contract and a token on the Theta blockchain, next class we're going to go through how to create a DApp to interact with our contract. And while I showed you the basics about TNT-20 and TNT-721 contracts, they can have a lot more functions, and just because the base functions have to be in there doesn't mean you couldn't add like 30 more functions to accomplish whatever your DApp is trying to accomplish. Thank you for watching this video, and I'll see you at the next course.